I just got my power bill. Oh wow, what can I do? Why is it so high? Tinker, please help me understand.
Hello. I fully understand your frustration, but after this, I hope you will see where your money's going and how to reduce the cost. For this session, we will look at a 50-inch LED TV, a gas furnace, an air fryer, a washing machine, electric vehicle chargers, and some phantom power. We will also look at the consumption of a washer. First, we will examine the 50-inch LED TV and run it for a period of time in using the power meter. Examine how much it consumed and at what price, and also see if that TV has any phantom power when the unit is not turned on. You will notice the watt reading is about 74 watt when running. The label on the set says 95 watt. There are a number of factors affecting this like volume, voltage, and the fact that all things are not created equal. Note the kilowatt hour in red. It says 0.24 kilowatt hour. The length of time this TV was running was about 3.5 hours. So how much did this cost? Well, it depends on the time of day, as the power companies have different rates for different times of the day and even seasons. But first, let's get some prices. You can see that our winter rates right now is between 9.8 to 20.3 cents per kilowatt hour. So depending when you're running your appliance will depend on how much you pay. I ran our test between 5:30 and 8 p.m., so let's average it to 13 cents per kilowatt hour. Since our runtime was 3.5 hours and only used 0.24 kilowatt hours, then it's safe to assume that the cost for 3.5 hours at about 74 watt cost about 3.25 cents. This does not include delivery charges and connection fees. At the end of this video, I will show you the extras I am being charged in South Central Ontario using Electra Utilities. We have two pricing structures now. One is time of use, and the other is tiered pricing, whichever works for you to save money. Example, if you're using 1 kilowatt-hour of energy in the morning, it will cost you 20.3 cents with time of use. But with tiered pricing, you would pay 12 cents up to 1,000 kilowatt hours. Then it goes up to 14.2 cents for the balance of the month use. We will look at a bill later. Now let's look at an air fryer. This is the unit we will test. It's rated, as you can see, as 1,500 watt or 1.5 kilowatt, so theoretically it could cost 25 cents if it's run for 1 hour. But we will run this and see what it will cost to do a steak. Okay, so it's not running 1,500 watts. It's actually consuming 1,656 watt when the heat is on, then shifts between heat and just fan to maintain the desired temperature. As the heating element gets hotter, the resistance changes. That is why the difference in the watt readings throughout the run. So as we can see, the total consumed is 0.34 kilowatt and the steak time was 25 minutes. So doing the math would be roughly almost 6 cents if the current rate was at 20 cents per kilowatt hour. All right, let's go to the next test. Let's have a look at the furnace. This could be tricky as it goes on and off a few times a day, but my Nest thermostat will show this so we can figure things out. I like to keep my home at 21 Celsius or about 70 Fahrenheit. Right now, the outdoor temperature is 4 Celsius or 39 Fahrenheit. As you can see, the gas furnace cycled a few times throughout the day, running a total of 5 hours and 41 minutes that day. And according to my power meter, it is running at about 300 watts that runs the electronics and furnace fan. Therefore, 300 watt times 5 hours and 41 minutes should be about 1740 watts or roughly 34.8 cents to run my furnace for that day. Obviously, outside temperature affects things, and so does the building envelope, meaning how well insulated we are. Again, this is based on 20 cents per kilowatt hour, but prices change throughout the day. Just to add, please note that so far we are in the middle of November in South Central Ontario. We had some mild temperatures and below freezing with a fair amount of snow that is now mostly melted, but more may come during the week. Ah yes, the Great White North. So far, we used almost 83 hours at 300 watts or 24,900, so almost 25 kilowatt hours, which could cost at the highest rate so far about $5. And if it stays the same way, Let's assume $10 for the month just to run the furnace. Just for comparison, a 2-ton central air conditioner could use 5 kilowatt of energy and it runs longer than a furnace. But that's another video. I am not set up to measure 240 volts at this time. The next item up for discussion is a washing machine. This is a full-size front load set for cold water and is auto set to run for 72 minutes. I wanted to use the LG wash tower, which is set in a closet, but could not get at the receptacle, so I am using a friend's machine. But while we wait for the cycle to complete, let's talk about the cost of charging an electric vehicle, which seems to a concern for people these days, for something to talk about. For residential use, there are two different types of chargers for electric vehicles. There is a Class 1, which is a 120-volt unit that plugs into a standard household receptacle. This type uses 12 to 16 amp, or roughly 1,500 to roughly 2,000 watts. A separate circuit is recommended. A small vehicle may have a 40 kilowatt battery pack, giving a range of about 150 miles or 250 kilometers. This type of charger is estimated to charge the vehicle at 8 hours at best. Obviously, a larger battery pack will take longer, but giving the info we have, it's 8 times 4 hours. Times your wattage, which could be, let's say, 1,800 watt would be 14,000 watt. Let's use 14 kilowatt at night at 10 cents per kilowatt hour would cost about $1.40. A larger vehicle may have a 60 to 70 kilowatt battery pack for longer range, which is also in an SUV, which cost estimated at 36 kilowatt of power used, or about 18 hours to charge the vehicle, at a cost of about $5. The Class 2 charger is a unit that runs at 240 volts and can use anywhere from 30 to 50 amp at that voltage, or be able to generate up to 12 kilowatts for a faster charge. Keep in mind that batteries do not really like super fast charging, as it will degrade the quality of the battery bank, and depending on the battery type, which is usually a lithium-ion, high-density pack could cause a fire if charged too fast without safety features. That is set up by the manufacturer. So an average level 2 charger, charging a 60 kilowatt battery pack, may take 7 hours at a cost of roughly $4, at 10 cents per kilowatt hour at night. And if you charge up every other day, would be $60 a month to charge your vehicle. This is all rough calculations based on information found on the net. Okay, now back to our washing machine. Wow, after 72 minutes, doing a very light load, just a bed sheet, I only used 90 watts of total power, which is almost free. So now I put in a twin comforter on hot water, although the hot water does not affect the power usage as the hot water is gas. But let's see if this machine is truly as energy efficient as it shows. Stay tuned while the machine does its duty. All right, so after an hour and a half on a heavy-duty load setting, the total power consumed worked out to just about 1/2 a kilowatt hour, and given the fact that we are in the prime time now of about 20 cents per kilowatt hour, the cost to do that comforter works out to be about 10 cents. But if it were a full load or partial load, the usage would roughly be the same. For our last session on usage for now, let's talk about phantom power. What is phantom power? It's the fact that an item is plugged into the wall and just uses energy even though you're not using it at this time. This seems to be overall a number not to be taken for granted. So let's check a few things out. Phantom power or ghost power is a common term used for electricity that appliances and electronics consume even when it's turned off. Or in standby power, it's used for PR instant on some appliances. If your appliance has a clock or internet connections, etc., it always consuming even a small amount of power. Your Google device or Alexa are always on standby, thus using power, not much but over a period of time, it adds up. A laser printer, for example, is plugged in, waiting for your request, thus keeping things like the internal heater, always keeping things ready. They keep telling you to turn these things off if not in use. But speaking from experience, the initial surge of turning things on can ruin the unit prematurely. A desktop computer in standby will use phantom power even if it goes to sleep or standby. Actually, by keeping it on, it will more than likely last longer than if you turn off the power every time. An example is my friend's desktop. Never turned off. The unit lasted over 14 years before it finally quit. Mind you, I did blow out the dust, etc., from the drive bays and power supply, But 14 years? That's a good life. The capacitors inside tend to blow on power up, which will kill the unit. Any electrons have a variety of discrete components that can suddenly blow or burn up with a power surge. So only turn off during a thunderstorm. A good example of phantom power would be a laser printer. As you see, the idle wattage is 5.8 watts, and after 22 hours, the consumption of 49 watt-hours, which basically would be about 3/4 of a cent, which is a laugh, but if you consider all the items in your home that may use phantom power, it does add up over time. However, it's probably cheaper to keep it running that blow it up with power surges on startup. For this last section for today, let's look at one of my power bills. If you can make it out, it covers the transition between our summer rates and winter rates. Example, our summer rate on peak was 15.8 cents per kilowatt hour, and winter's 20.3. That hurts a bit as my monthly power bill is more. My average consumption is about 20 kilowatt hours per month, which is not terrible, but I do supplement with a small solar pack. Plus, there is only 2 people living here. So I urge you to look at your bill and see when you are using the most power and keep it within the off-peak zone. We also get a percentage rebate of a few dollars, but one never knows when that will disappear. I hope you found this info session informative. If you found it to your liking, please subscribe and give it a like. I will come up with other items to help you and your family to make life a bit easier until we meet again. I am the Tinker.